Challenge 4 is for Olympiad level. Okay, you qualify for USAMO or you qualify for USAJMO, you're in this class. Okay, you're in this class. This class cover a lot of topic. So you cover everything in MC3, and then additional topics like quadratic residue, Diophantine equations, recurrence, and inequalities, mathematical induction, and functional equation. You see, there are a lot of topics. So this one is the only one that's 1 year is not enough to cover all the topics. So to cover all these topics is going to take about 3 years. Okay, but every year before the USAMO or JMO time, I'm going to do review the common topics. Okay, the induction, the inequalities, the pigeonhole principle, those will be reviewed. Okay, but every other time we're going to get into detail, the in-depth about different things, inequalities and the functional equations and all these other kind of techniques. Okay, all right. So, well, this is I would say that I have this class is at a level comparable to Wood. Okay, so let's look at the number 12. I want to prove for positive numbers, ABCD, we prove this. Okay, so the question like this is the specific type of trick to do inequality. So yeah, so Lillian already saying this left hand side is trivial, weak bound. Well, it's basically how do we do the left hand side? You look at the fractions, okay? Because these are positive numbers, the fractions will be smaller if your denominator is increased. So what about we increase every denominator to the full a plus b plus c plus d, right? It's going to become smaller. And b, a plus b plus c plus d plus c over the same thing plus d over the same thing. So everyone is smaller, right? Everyone is smaller. So then that's exactly equal to 1. Because the denominator is all the same, and numerator is a plus b plus c plus d. Okay. All right. Okay. So now, because every fraction is reduced to smaller number, every fraction is reduced to smaller number, then the whole thing is reduced to 1, and then that's, of course, this is greater than 1. Okay, so now how about the other side? Less than 2. Less than 2. This case, we don't increase the denominator, we decrease the denominator. Okay, we decrease the denominator. So the denominator, if we, let's say, cut away one number, that's decreased, so the number become bigger, right? And this one we cut off c, then that become bigger because those are all positive. And for the third one we cut off b. For the fourth one we cut off a. These two put together is 2, and this is 1. Okay, these two put together is also 1. So now we have 2 increased. Okay, increased every fraction, and then we get 2. So of course the original is less than 2. All right, so that's how we do this both sides. All right, so if you're not to that level yet, that's fine, don't worry. It is the MC4 level. Okay, after you qualify for Math Challenge 4, we'll go into this. After you qualify for USAMO or JMO, we go into this. Okay, so let me see another one. This one will be some more advanced. If you don't get this one, that's totally fine. And if you are at this level, let me talk about this. Okay, so let's look at this question. We have among any 7 real numbers, A1, A2, up to A7, there exist 2 denoted AI and AJ, so that you do this one, and that's between 0 and square root 3 over 3. Okay. All right. So yeah, so people already noticed that the expression in the middle is actually the tangent formula. Okay. So what we can do here is, okay, yeah. So if you're not to this level yet, don't worry. So if you get the some of the earlier questions, that's fine. Okay. So here, let's look at these. So the numbers are real numbers. All of them can be represented by a tangent of certain angles. So the tangent, okay, let me talk about A1 is tangent of B1, let's say. And A2 is tangent of B2. And so on. Okay, A7 is tangent of B7. The thing here is the B1, B2, B7 can be in a same range. Okay, the BI can be between negative pi over 2 or 90 degrees. That's the same thing. Okay, and let me use degrees. Negative 90 degrees to positive 90 degrees. All right. So in the diagram we can draw. It's here. Okay, yeah, these are easier. These are of course easier, but you have to cover these spaces in order to do the JMO problems. Okay, so you can do this. That's great, but this we'll have to say these are the more fundamental things we need to cover in order to get combine them together into the USAMO or JMO. Okay, so those problems will, at least for those JMO or USAMO, at least they need 3 tricks to do this. Okay, so let's break it down. Okay, let's say among this range, all those 7 number of B belong to this range. All right, so if we break it into 6 different angle of 30 degrees each, we have a 1, 2, 3, 4, 5, 6. Okay, so 6. Then we have 7 numbers. There are 6 ranges. So that means what? There must be 2 in the same angle, in the same range. So 2 of them. I don't know which 2. Okay, I don't know which 2. They have to be the difference between them has to be less than 30 degrees. So let's say BI and BJ, the difference is less than 30 degrees. Okay, it's greater than 0, less than 30 degrees. So then if you rewrite the tangent, okay, the tangent of all 3 sides, tangent BI minus BJ, the writing on board is not easy, as less than tangent 30, greater than or equal to 0, and that's going to give you exactly this inequality. Okay, that's a pigeonhole principle. Pigeonhole principle. Okay, and all right. So this is for those of you who are at that level, they can understand. And if you don't get this last question, don't worry. Okay, don't worry about this. And well, we're over time, and let's see. I hope I've given you a flavor. I've given you a flavor of all the classes we're going to do, and then what we're going to cover in the classes. Of course, we cover a lot of more topics in each of the classes, and we will start from the beginning and